Okay, here we go. First of all, welcome to chemistry.
Yeah.
No, this is our first chemistry today.
That's sad.
The rest of it was learning.
The rest of it is just learning how to do chemistry.
Now we're doing
I had to
it.
teach you math. Anyway, you have in front of you, remember, if you remember one of the first couple of days of school, I said to you that when things are easy, take advantage of those opportunities to counteract when things get hard. Anyone remember me telling you that?
Yeah.
Okay, now, at that time, I classified, get rid of that, please. At that time, I classified the apparatus quiz as easy. It should have been easy. A small number of you took advantage of that. Are you relaying to Judea? What's that?
After like
The-
tools and stuff.
No, the apparatus. Yeah. So some of you did not take advantage of that. Interestingly enough, nearly all of my honors students crushed that. Were not as many as the not honors didn't. That has nothing to do with
Honors.
no, yeah, it's just how much effort level. And I'm telling you what, right now, for some of you, that's the only difference between honors and regular. It's just the amount of effort that you have put into classes up to this point in your career. Anyway, with that being said, I just saw something I need to change. Your foot was right next to it. You didn't even know it. That's right. It wasn't your fault. That was me. Nobody sat there when I put that there. Anyway, I considered the apparatus quiz to be very, very easy. I considered up to this point in your career the dimensional analysis quiz to be one of the harder things that you've done this year. I'm going to guess most of you agree with that. And I'm going to put the significant figure quiz somewhere in between. I think most of you would agree with that too, right? Well, you now have in your hands all three levels of difficulty. I'm going to talk about the easy one first. I'm going to hold off until probably tomorrow to talk about the other two levels, but you're not responsible for those other two levels until after this quarter. So we'll get to that when the time comes. Well, I should say after the unit that we're about to enter, which is going to be done at the end of this quarter. So there you go. First off, the easy one is the element quiz. You're going to be responsible next Tuesday, it's a week, for knowing the following element names and symbols. Name and symbols. Now, if you guys have highlighters, that might be a useful thing. If you don't have highlighters, you can use other things. You can just mark, check, put an X. I don't care. Charlie, you gonna be able to see that or not?
I think I can see the symbols.
I actually think I know that, and I think I have a copy of that online. I will tell you that actually came from a website. So I'll give you the link to the website so you can just look at it there if you want.
Sure, got it.
That website might actually be somewhere on Canvas, but I'm not sure. Okay. All right, here we go. Now, one of the things I'm about to do is find out what you guys learned in physical science. Here we go. Group 1A. Group 1A. You are responsible for hydrogen through cesium, CS. Hydrogen through cesium.
You said CS?
I did.
Oh, okay.
You
And
went
that's just the row?
you went the other way.
Yeah.
Clearly, you didn't distinguish between group and period.
Like hydrogen.
Hydrogen, H, through cesium, CS. Group 1A. If you can't keep up, I'll do it for you in a little bit. or someone else can. Group 2A, beryllium, Be through barium, Ba. Group 3. Is that yours? Really? Okay. Group 3. Notice how I said that group. Scandium. You guys need to be responsible for both systems of numbering the group. Group 4. Titanium. Ti. Group 6. Chromium through tungsten. Cr through W. Group 7. Manganese. Mn. Group 8. Iron. Fe. Group 9. Cobalt. Co. Group 10. Nickel and platinum. Ni and Pt. Group 11, otherwise known as the noble metals, copper through gold. Cu through Au. Group 12, zinc and mercury. Zn and Hg. Group 3A, boron through gallium. Well, yeah, which brings me to this. I got this periodic table off of a. Oh, I see what you're doing. I got this periodic table off of a website somewhere that is based in the UK. So this periodic table uses the spelling that most of the rest of the world uses for the elements other than us. So for example, look at the middle element in that last group I just mentioned. The entire rest of the world calls that aluminium. We call it aluminum. Either spelling I will accept. I will accept, notice how I'm saying this and why I'm saying this, I will accept either spelling. Okay?
How do you say
It.
That's weird that we pronounce like this.
Aluminium. One other thing, and you guys may not be as familiar with this element, which is why I didn't mention, that's why I forgot to mention it the first time. If you look over in group 1A, the last element that I gave you guys, cesium, that is the rest of the world's way of spelling that element. If you see other sources from the US, it would be CESIUM. Once again, I don't care which spelling you go with. As long as you go with one of those. All right, moving on. Where are we? Back at 4A now?
Yeah, 4A.
Carbon through lead. C through Pb. Group 5A. Nickel. I lied. Nitrogen through bismuth. N through Bi. Group 6A. Oxygen through tellurium, or O through Te. Group 7A, fluorine through iodine. F through I. Group 8A, helium through radon. He through Rn. But wait, there's more. Down to the lanthanides. Lanthanum. Down to the actinides. Actinium. Uranium, number 92, U. Plutonium, Pu. And americium, Am. How many do you have? Let me know. Well, it's less than half. No, sorry, it's exactly half. My bad. It's exactly half. Oh, I thought you were keeping track. I thought you'd know that right off the bat.
So 50.
50 who?
51.
You're a little off.
So what do we?
Well, I already told you. Names and symbols.
59.
Ding, 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 ding. There should be 59.
I think I was miscounted.
If you did not get 59, one, either learn to count, or two, consult with a colleague to see if maybe you made a mistake somewhere. I know. That's usually the case.
Quick question, the one under gold, how do you pronounce the one under gold? I'm just curious to know.
I don't know. I don't know it. Oh, Rentgenium.
That's how I say it, right?
Sure. All right. Is everyone getting their 59?
Working on it.
Is everyone getting their 59?
Should have
59.
Oh, absolutely sure. There have been 59 for the last 12 years. Well, then you may have missed one somewhere.
Or Miss Mr. Lehman, what's in that box colors?
Oh, things we'll play with later this year.
Really?
Oh, yeah. Well, I will play with, but you'll get to look at.
What's
If
like,
you take organic chemistry in college, you get to play with them yourself.
yeah. What's your favorite?
How do I keep getting
what's the most
67?
Don't have one.
What's the most dangerous
Yeah,
experiment
there's
with this class? Like, we will.
I don't know. Depends on which ones I decide to do. You'll have to ask Allie about that one. Oh, by the way, does anyone remember me telling you a story about a student that caught a lab station on fire?
Is that her?
That was seriously the jackal.
Whenever Addie and I are partners, fire just.
If you just got it wrong. I recognize. Mr. Ryan, I think.
But you notice that I never said a name.
I don't know.
What?
Oh, was I supposed to?
I'm
Yeah.
58.
I'm sorry about
I
that.
didn't count.
I have 57. I'm so confused. People just the same.
I've been getting 59, and all of my students have been getting 59 for the last 12 years or more.
No,
I got 58.
I got 58.
I think
Alright,
everybody.
who has 59? So I can see your paper.
Zoe does. Of course, Morgan does. Makes sense.
Oh,
I
there's
didn't know
more.
Yeah.
59, as always.
Morgan, how's your day
So
today?
you guys missed one somewhere. No, I meant missed writing down
How
one.
I miss it? I know I can count.
So if you guys are both getting 58, you're looking on each other's.
57, and we have the same one.
All right, anyway, moving on, because we have other things to do other than count.
This is more than we need to know it.
Yeah, I agree with that.
I'm just gonna memorize all.
All right, or there you got that. Now, next Tuesday, there will be a quiz, as I was saying earlier, on the symbols and names. Now, here's where people have screwed up over the years. Now, like I would say, this I would classify this as one of the easy things, so please take advantage of that. Could someone please tell me what this element is?
Magnesium.
Just, no,
Magnesium.
This element does not exist because one, it would be a chemical compound. How would I know it's a compound?
Capital.
Because there's two capital letters.
You just made a little one
A small uppercase letter, not a lowercase, makes. So the correct symbol for this would be, okay, what is the name of this element?
Neon.
That does not exist. There is not a single element listed here because an element would have a capital letter in it. So once again, a large lowercase letter, not an uppercase, makes. So when it's uppercase, use uppercase letters. When it's lowercase, use lowercase letters. Right, ladies?
Right, yeah.
Wait, why only the like?
Rarely do I get yacht guys that do one of these, but sometimes I do.
Get guys to do one.
What's that?
Put a lowercase for an
Where they'll use a lowercase letter, a big lowercase letter to mean an uppercase, and a small uppercase to be a lowercase.
But was that sarcasm, I think?
No, actually, no. That's just more of an observation.
Well, I can never tell with him.
I know. Next, what are some other mistakes that are going to be made? Give me a sec. Oh. Would anyone like to write the symbol for the element uranium up on the board, please?
I'll be the one who fails.
Oh, it's gonna be.
You guys see how smooth she was at that?
It's gonna be how to use.
Go.
Oh, well, I know.
It's you.
I bet she's just gonna get it wrong.
I feel like it's just. I feel like it's like you have like.
No, I'll take the. I know it's gonna be wrong, so I might as well just do it.
You're left-handed.
Yes.
I did not know that. Why?
Just
Such
keep
an
it
attitude.
down. I like how he's not even looking.
Remember how easy this was? Oh, here we go.
And now, I got a high five.
Because I see this about half the time.
That's a lowercase.
That's a lowercase u.
Boom. Shakalaka.
Okay. Next thing that will get screwed up.
Fluorine.
That is not fluorine.
That's floury.
You know why it's not fluorine?
Not have a letter.
Because there is urine in the fluorine.
That's
Do
not.
not put urine in your
Fluorine.
fluorine.
Well,
Is it just with a O?
It's you.
Okay, that makes it easier to do.
Is it just with an O?
No, some people avoid the issue by just putting an O.
It's F-U-O-R-I-N.
You'll notice that there is no urine in this fluorine.
There is flu in it.
Oh, yeah, right.
So
Flu
flu.
in it.
You don't want to pee, you want flu.
All right, anyway, moving on. What else? What else? I'm trying to help you out. These are the very common mistakes that happen. Put that away, please. Unless it's water.
Only if it's an emergency.
It's
Vitamin water.
not. It's not
It's
water.
vitamin.
Yes.
See that brown bottle sitting?
Yeah, it's right over here. I will let you borrow it until I need it.
I just want a sample.
I know, me too. Well, then, why don't I just take a sample?
No.
Okay.
Give me the bottle.
Moving on.
Add it.
What else? What else? What else? What else? I've covered just about everything.
Stop. Sturdy structure.
Okay, that'll work. Now, why did I pick the elements that I picked? Some of them I picked, well, actually, most of them I picked because these are the elements that you are going to encounter either on a daily basis in your life and or in this class. Those are the ones we're going to use over and over and over and over and over again, okay? A couple of them I picked because of their locations on the periodic table to draw you to a particular location. For example, actinium and lanthanum. Okay, because we're going to refer to the actinoids and the lanthanoids at various points in the year, so it'd be nice to know that you guys knew where those were. Some of those I picked for their chemical significance. For example, I picked titanium mainly because I'm constructed somewhat of titanium. Yeah, got 2 hip replacements.
Oh.
So there you go. Thank you, Mr. Homan.
If you walk past the thing,
Oh yeah, every time.
What happened?
He is Titanic.
I wore them out. Yeah. Let me see. Uranium. Uranium's actually on there twice for 2 reasons. Uranium's on there. I picked uranium for 2 reasons. One, the chemical significance in that every element after uranium is man-made. After. There's a lot more after 92 because there's 118 elements. Okay. Anyway, but the other reason I picked uranium and plutonium is more of a historical significance.
Is it when you drop the nuke on
The first 2 atomic bombs. The first one was made from uranium. The second one was neptunium. Or sorry about that, plutonium. I lied. Jeez, plutonium. Yes. Yeah, because you don't need to know any of this stuff. Go.
I can wait.
Good. I picked americium for a chemical reason.
What did I use that?
No, not because of America. Do you know? I actually had someone in my last class today actually know. None of you do. That's okay. It's the first. It doesn't happen very often.
You probably have my brother.
Anyway, does anyone have a smoke detector at home?
Yes, my dad took him out.
Is it what's
It's
in
a
there?
It's in there. Why did you? Just out of curiosity.
Oh, so one night it was beeping.
Okay.
and he didn't have a battery, so he just ripped him out.
Okay. Anyway, most of the smoke detectors use americium as their, one, it's a radioactive element. Many elements are radioactive. Did you know that you're radioactive?
Yeah.
Just a little bit. Anyway, americium is also radioactive. I know you don't know exactly what that means yet. That's actually going to come up here next week in the process of learning something else. Okay? Wait, what's today? Wednesday?
Yes.
Might come up Friday. Anyway, moving on. It's radioactive, so it gives off these particles. Well, the americium in your smoke detector is surrounded by this detector, some sort way to detect these particles, and if that rate of the rate, it's a constant rate that it breaks down. Okay, that rate's very well known, and so this detector is expecting all these particles to be hitting it, and if they don't hit it at that rate, then something's wrong. So what's causing that to happen? To not those particles not to get to the detector? Smoke, right. So it just interferes with that process. So the alarm will go off. All right, anyway, moving on. I'm just showing you some things that... Oh, radon. The last noble gas that I gave you guys, the Rn on the very bottom right. Okay, has anyone's family purchased a home recently or moved? Okay, you guys did? A lot of you guys. Okay, do you remember your parents saying anything about a radon test being done? Do you remember this?
Yeah.
Did you guys have radon?
They had actually a good amount, but they were getting rid of it. They were like doing this,
They had a good amount.
but not enough to harm us.
There we go. Okay, what radon is, as it turns out, a poisonous gas. It's kind of has a tendency to accumulate in the ground in little pockets here and there throughout the world. And occasionally when you build a house, you have to dig down in, and sometimes part of what you dug down in gets into one of those little pockets and starts getting into your house. So whenever you buy a house, you'll have to get it, have it tested for radon. So some of you actually knew that. Go.
Was that the same thing with the building that was, or that school building like a long time ago, and they had to shut it down because there was like radioactive stuff under the school?
It was what school? Wasn't it River Valley?
Oh, River Valley, that was a whole different thing. If you're talking about River Valley, that was a whole.
Yeah.
That was built on an industrial site.
Yeah, it was like right down to chemical.
Like
They gave like a lot
interestingly enough, when I was in high school, I played on the football
that's what
field.
My parents said too.
And you know who I played against? Who was on the team that I played against? Our current head football coach.
My dad also
Ooh,
played for
really?
Hayes
Yeah.
too. So.
Yeah, him and I played against each other in high school,
You
played
and
with
your
each
dad
other
played?
in college, and then we coached against each other.
The head coach.
Where'd you play in college?
Huh?
Where'd you play in
Muskingum.
college?
Yeah.
Okay, radon stuff underneath the ground. What's the stuff, the element that's in old paint? We
Lead.
have to have tests.
Lead.
Lead?
Lead.
Okay. I can remember.
You know, that element that was one of your unknowns?
Yeah, it.
Anyway, moving on.
Lead is not really lead.
I got that. Oh, next. If you have either a really dark, like a marker or something like that, what I want you guys to do, and it doesn't have to be, you can just do it in pen or pencil, is I would like you to reproduce this line accurately on your periodic table. Reproduce that line on that periodic table. What'd you do?
Oh, the stairs one?
Yeah, bro, we did this.
We did that.
What'd you say? How?
I forgot the
You have a
stairs.
chance. You started in the right place.
To separate.
Did you guys get that figured out yet or not?
Yeah.
What was it you were missing?
Oh wait, no.
No, you didn't get it figured out.
Signs.
All right, now, I know you guys have gone over this before, but every element to the left of this element, of that line, are known as the metals. All of the elements to the right are known as the
Gases.
no,
No.
no, no.
Non-metal.
You knew this was coming, didn't you? Every year, 18 years, 28 years of doing this every single time. I actually
What
threw
is it,
something
Allie?
to somebody. Really
Allie, quick name it. What is it?
No. Now, I'm curious as to why so many of you said gases. When boron, carbon, silicon, phosphorus, sulfur, arsenic, selenium, thorium, iodine, and acetine are all solids. Bromine is a liquid,
Non-metals.
non-metals. And thank you, Xander, for doing exactly what 15 other people in the room had the same question you had.
Wait, what?
I'm going to say it here in a second. You did it exactly on cue. I could have just pointed. If I would have known it would have been you, I would have been. Okay, so here's what happened. I said boron, carbon. You said carbon's a solid?
Yeah, it is. Carbon dioxide.
Okay, and there we go. Now, many people in the room, and it's not entirely your fault because either one, you were never told this before, or two, you should have been told this before. You guys all have physical science. But two, you read and hear all kinds of things about amount of carbon in the atmosphere. Well, what's the atmosphere made up of?
Yeah.
Gases. So it seems to imply, when you say, oh, the amount of carbon that's in the atmosphere, many people that don't think about it go, oh, well, carbon must be a gas. Well, the element carbon is a solid. We'll talk about that here in a second. But there are compounds that carbon is in that are in the atmosphere, one of which is carbon dioxide. The other is,
Carbon monoxide.
no, I hope not, or we'd all be dead.
I have a different one.
Time out. I will demonstrate.
Natural gas.
Otherwise known as methane.
Methane.
Methane. Does anyone know the formula for methane? Charlie just sucked up a big bunch of it.
Gee, thanks.
Does anybody
Drank some
know?
fart juice.
Does anybody know
Oh,
the formula for
CO.
methane? It's not CO.
Yeah, that's all I got. But I got a C in there.
CH4. There's about 4 or 5, there's a handful of chemicals that if you guys walk out of this class without knowing their names and formulas that I'm firing you all, you can't pass the class without that. One of them is methane. Methane is CH4. otherwise known as natural gas, which is an odorless, colorless gas. Right, Charlie?
Yep.
We talked about
Oh
this,
yeah,
didn't we?
because you added
Yep.
like
All right, anyway. So between the methane and carbon dioxide that's in the gas or in the air for various reasons, that's where the carbon is coming from. Okay, so it's carbon-containing compounds, not carbon. Carbon has. You will not be tested on this word. This is just one of those things that you just learn just because you can. Carbon has 3 allotropes, which means forms. There are 3 forms of elemental carbon. There's 2 forms of sulfur. Actually, it's 3 forms of sulfur, I think. There's a couple of forms of phosphorus. Some elements have more than 1 form or allotrope. You guys are actually very familiar with at least 2 of the 3 allotropes of carbon, and possibly all 3. Would anyone like to throw one out there? Carbon dioxide is a compound. It's not an element. 3 ways that the element carbon exists that you guys are familiar with, probably at least 2 of them. I will give you a hint. Not you. Not you. All but, I think 2, not you, all but 3 of you are currently using one of the forms.
Graphite.
Graphite. Graphite is pure carbon, otherwise what you guys call pencil lead. Now, I brought this story up in one of my other classes, and as it turns out, one student actually was familiar with this. Well, shoot, how much time? Oh, plenty of time. Here we go. You guys don't have to write this down. Again, this is just wonderful, whoa, information to have.
it's a honeycomb.
Ah.
I'm seeing back.
Let's go here, 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 here. Let's go here, here, here. Okay, so now you see all these little lines. At the intersection of each line is a carbon atom. And all those little lines represent a covalent bond, which you may or may not remember from other classes, okay? Now, notice that that's a 2-dimensional structure. Would you guys agree?
Yes.
Okay? There is no 3rd dimension. So that's a sheet of carbon atoms that has 6-membered rings that are all interconnected with each other. Okay? What is graphite? It's a bunch of those sheets stacked on top of each other that are loosely attracted to each other. So this sheet would represent basically what I have on my paper, except graphite is just a bunch of those sheets all stacked on top of each other that are loosely connected to each other. That's why you're able to use it to write with, because what happens when you write? It slides right off and stays on the paper, right? And I'm sure some of you gentlemen, young gentlemen, did this in about 4th grade or 5th grade or last period, where you took a pencil and just went like this all over your, and then kind of scooped some of that up with your finger. You did that last period? Yeah, okay. And what did you notice?
My finger changed colors.
Yeah.
It
Did
was
it
shiny.
slippery?
Yeah, like it's
Slippery, and the reason it's slippery, as I said, each of these sheets is very loosely bound to the other one, so it slides right off. It's used as a lubricant. And so a great example is, anybody have an old car? Which actually has a lock in the door that you actually have to insert the key in. Okay, and if it's an older car, which is why you have it, right? Does that lock sometimes not work? So you have to lubricate that. Now, you shouldn't use oil, because all the oil does is attracts more gunk that
use graphite.
makes it worse. So you use a graphite spray. Is that what you did?
It's like easy wrench or something. It's called. It's red.
It's graphite spray.
Yeah.
Okay, so it's a powdery powdered lubricant, and again, it's lubricant because those sheets can slide right off. Yeah, just guys, just ignore it. It's like a little elf, okay? Just ignore it.
He goes to the Y all the time and he gets mad at us.
His one kid just came down the stairs.
Just ignore him, okay? Anyway, moving on. Time out. He's gonna try and get over. Next. Now, I don't know how much you guys pay attention to current science. Okay. There's this substance that they have finally been able to like isolate and do things with called graphene. Has anyone heard that word yet? Okay. So what they're doing is using graphene, I'll tell you what that is here in a second, to basically package small amounts of other chemicals, whether that's drugs or other things, but in a very, very small package, like micrograms worth of stuff. All graphene is, they finally have been able to do it, technologically speaking, is one of the sheets that I was just talking about from graphite. So we'll take that sheet and wrap other things around with it. I know, it's okay. Oh. Well, we're trying to keep Sammy out.
That's his name.
Anyway, moving on. That's one allotrope. You guys very familiar with that?
Now we are. Are you looking for contacts?
Okay.
Earrings.
Oh, no earrings. Sorry.
Is
I have a nose piercing.
Is it,
No, yeah, that's not what I want.
is it the back part? or the-
Oh, we got a chance. No earrings. No one in here. Now, typically it's going to be the young ladies that might, that have these. Another allotrope of carbon, pure carbon. Diamonds.
Oh, I have it right here.
Oh,
It was the one.
I looked on the wrong side.
LOL.
Oh, well, I didn't know you were married.
Yeah.
Anyway,
How long
Anyway.
together?
diamond, pure carbon. That's all it is. Now, would you confuse a diamond with graphite? No, not in any way whatsoever, okay? So both of them are pure carbon, just the way the atoms are arranged is different. What's the most common form?
A diamond?
No, of carbon. No, it's not. We've already done two.
I'm intrigued.
This
Okay,
is the one that we don't know.
where do these lights come from? How do your
LED lights.
Light bulb.
why do the light bulbs work?
Electricity.
And where's the electricity come from?
I'm losing myself.
What?
The lightning bolts.
No.
Electromagnetic stuff.
Electric generators.
The sun.
No.
Power plants.
And what does a power plant use as a fuel?
Coal.
Yes.
Oil.
Fossil fuel.
Coal.
That's what I meant.
Dude, it said Santa Claus.
Now, in Central Ohio, actually, I think our electricity, I don't know exactly where all of the electricity is coming from, but it's probably somewhere down on the Ohio River, which means it's either going to be a coal-powered plant or a nuclear-powered
Water powered.
nuclear powered, because there's a couple of water or nuclear plants down there. But anyway, coal is the third allotrope of carbon. I don't think you're going to confuse coal, graphite, and diamond with each other. But they're all made from pure carbon.
Oh, that makes sense. Now, is it like extreme heat and pressure on coal?
Eventually. Yes.
That is.
I don't know. Ruby is not carbon.
No, it has to be.
I don't know what it is, but it's not carbon.
What about a
Moving on. Next. What is the format of the quiz next Tuesday? Well, first of all, have you guys gotten the hint that spelling counts?
Yeah.
Excellent.
That's what I'm working on.
Yeah.
You have to spell
I don't know how to do this though. I don't know how else you can do it. Oh yeah, you
Do
can.
what? That's not how you say it.
Today.
That is not how you're supposed to say it.
Yeah, what do you think beryllium feels like when you spell his name wrong? Okay, so where I'm going with this is spelling counts. Next, oh, we're gonna get there. We're gonna get there. Next, here's the four. Usually people ask at this point in time because they're focused and they would really want to know. That hasn't happened yet, so I'm going to do it. So here's the format.
You're giving us a sign.
Oh.
Carving.
Write it on the line. That is easy.
So it's
Oh, the song is gonna be strong symbol.
thanks for clarifying that, by the way.
There will be 15 symbols in which you provide the name. There will be 15 names in which you provide the symbol. Now, many of you have already made the decision correctly to make flashcards. That would be a very good idea, but the making of the flashcards usually isn't exactly all that's needed. My suggestion to you, once you've got those made, sure, get familiar with them, the symbols and the names and so on and so forth. But because the spelling counts and because the writing of the symbols correctly counts, also spend some time actually writing them out as you're doing them. Now, here's another mistake that can often be made. And I've had students come up to me, but Mr. Lehman, I spelled it right. No, you clearly didn't. Here it is. But that's what's on my flashcard.
Too bad.
That's what you wrote.
So, if you've decided to make flashcards, please spell everything correctly and write the symbols correctly. Any questions so far? Next, this is to help you out. And I know that you guys all want to pack things up because you're used to your other classes. But there's 3 minutes left. I'm going to use them because this is going to help you. What's up with sodium?
Na.
Na.
Oh, it's going
What's up with iron? Fe.
Oh, is that
What's up with silver?
AU?
Ag.
Oh,
Okay. Tomorrow, someone please remind me
I will.
that I want to spend some time, because I think it's going to help you with your remembering, to talk about the Latin and or Greek names where these came from, to help so you guys have a better feel for why the symbols are what they are. Now, I'm going to guess you guys probably know at least 20 of them already.
Yeah.
Yeah.
I mean, you could almost guess
Like
a
you're
lot of
reading,
them.
Like what is
But I'm not gonna guess. I'm gonna spit.
Guess what it is?
E-R-N?
It's
Well,
two,
there's
it's
two
two
letters. There's only two letters.
No, there's actually, for boron, there's only one. Guess what it is?
B.
Excellent.
Carbon C.
Yeah. I mean, so a lot of these you guys know. What's your question?
I was gonna.
Time out. Stop.